Today's lesson is showing how to go from rational expressions to radical expressions and radical expressions to rational expressions. So let's look at, we have three parts to a rational expression. We have the base, and then we have our exponent is going to be a rational number, which is a fraction. So we're going to have the numerator and the denominator. And then the radical has three parts. Has the index, has a base, and then we just have an exponent. And this exponent's going to be a whole number. Okay, so the base obviously is going to stay as the base. The numerator becomes the exponent, and the denominator becomes the index. So let's remember this, and let's do a couple problems. So we're going to write each expression in simplest radical form. So we're going to write our radical symbol first. The base is x. The numerator, we said, becomes the exponent, and the denominator becomes the index. So we have the fourth root of x cubed. Now let's go and see, let's check this. So to check, I'm going to store a number for x. I'm going to put in my problem. So x to the using alpha y equals to get my fraction. Okay, and now let's put in the fourth root. So we're going to do 4 math 5 x cubed. Notice these two numbers are the same, so that means we have the correct answer. All right, let's move on to example 2. We're going to make our radical sign first. The base is x. The numerator is my exponent, and the denominator is my index. Now this is not in simplest radical form because I have 7 x's inside the radical, and I want to make groups of 3. So how many groups of 3 can I have? I can have 2 groups, so x squared, and the cube root of, I have 1 remaining. And I would like to go back and check this also. You can do that on your own. Okay, let's look at the next two examples, example 3 and example 4. Look at them first. They look very similar. Well, we're going to have two different answers here. First of all, I'm going to make my radical sign. What's the base in example 3? Is it 5x? Is it just x? What's being raised to the 4/9 power? Just x. So x is the base. 4 is the exponent. 9 is the index. And this 5, where does it go? Well, it's going to go on the outside of the radical. And we're going to check it. You can check that. Before we check it, though, is it in simplest form? Well, we have 4 x's and we want to make a group of 9. So yes, it is in simplest form because I can't make a group. Now let's go over to example 4. What's the base here? What's being raised to the 4/9 power? Well, 5x this time. And let's leave it in parentheses. And exponent's 4. And my index is 9. Now, this is not simplest radical form because if I had just 5x to the 4th power, could I simplify that? Yes, I could. I could do 5 to the 4th power, and I could do x to the 4th power. So 5 to the 4th power is 625, and x to the fourth power is x to the fourth. So we have the ninth root of 625, x to the fourth power, and we want to check that. You can do that on your own. Okay, let's look at these three. We have x to the 2/5, y to the 4/5. Notice now that we're going to go from rational to radical. And I have two. In this first one, somewhat simple because we're looking at our denominators because they become the index. The denominators are the same, so we're going to say that we have the fifth index. X squared, y to the 4. Now check it. Okay, the example 6, not as easy. Why? Because my denominators are not the same. So since they're not the same, then I have to try to make them the same because I only want one radical instead of two. First thing I'm going to try to do is see if I can simplify the bigger one. So here 8's biggest, so 6/8. Can I simplify 6/8? Here I can. Both numbers can be divided by 2 to make 3/4. So now I have x to the 3/4, y to the 3/4. I have the same denominator, therefore I'll have the same index, which is 4. So we have x cubed, y cubed. Now I want to check this. Remember, let's go back and check this together. So we're going to store a number for x. It's 2.5. Store for x. I'm going to store 3.5 for y. And now I'm going to do x raised to the 3/4 power, y raised to the 6/8 power, and now we're going to do fourth root. So 4 math 5, x cubed, y cubed, x cubed, and y cubed. And we have the same number, so that means we got the correct answer. All right, let's look at example 7. Denominators are not the same. So first thing I'm going to try to do is make the bigger denominator smaller. Can I reduce 5/6? No, I cannot. So that means I'm going to have to go up. And how do I take 3, the smaller one, and get up to 6? Well, I multiply by 2. If I multiply the denominator times 2, I have to multiply the numerator times 2. So here we have x to the 5/6, y to the 4/6. Now I have the denominators the same, so I'll have the same index. So x to the 5th, y to the 4th. And go check that. And now let's look at going from radical to rational. Kind of the same point, except we're going backwards. So what is my exponent for all of these? The exponent for 256 is 1. Now, the exponent is going to be my numerator, and the denominator is 4. So x to the 13th fourths, y to the 16th fourths. Now let's look at all my exponents. Can I reduce 1/4? No, I cannot. Can I reduce 13/4? No, I cannot. Can I reduce 16/4? Yes, I can. 16 divided by 4 is 4. So I want to make my exponents as simplest as I can. And there's my final answer. And we can check. Go back and store number for x and y. Put the problem in. And then put my answer in and see if they are the same. Let's look at example 9. I have an exponent of a 1 for the 5, a 1 for the x. And what's the index here? This is square root, so the index is 2. So I have 5 to the 1/2 power. 1/2 cannot be simplified. X to the 1/2. 1/2 cannot be simplified. And y to the 3/2. 3/2 cannot be simplified. So check your answer and see if it is correct. Let's look at this next one. I have a to the 3/6, b to the 6/6, c to the 12/6, d to the 4/6. Let's go back and see if we can simplify it, and I believe we can. 3/6 becomes 1/2. 6/6 becomes 1, so b to the 1st. 12 divided by 6 is 2. And 4 divided by 6 is 2/3. Now go back and check your answer. When I'm going from radical to rational, I can have different denominators. Okay, let's look at the example 11. We have a base of 3x. It's in parentheses, so let's keep it there. 5/3. 5/3 cannot be simplified. Go and check your answer. Here's some problems for you to work. Here's some more problems for you to work.